We are discussing simplifying expressions with rational exponents. We're going to need to recall our properties of exponents, and then these rules will be extended from integer exponents to rational exponents. A quick reminder, rational numbers are numbers that could be positive or negative whole numbers like 1 or -3 or 0, but they could also be decimals or fractions. So our first property that we're going to remember is the product property that states that like bases multiplied, we're going to add our exponents. Similarly with the quotient property, like bases divided, we're going to subtract our exponents. I can't quite get that all highlighted, but you're okay. Zero exponent rule. A base raised to the 0 power will always equal 1. Now you have to be careful there. If there's a coefficient out front and it is not being raised to the 0 power, then you must apply the zero exponent rule and then multiply by the coefficient. Our power rule, raise a power to a power, you're going to multiply those exponents. And then power of a product, similar with power of a quotient. Inside your parentheses, if your pieces are connected through multiplication or division, you can distribute that exponent. You can see that for power of product as well as power of quotient. And then expanded power means if everything inside your parentheses is connected by multiplication or division, then you can apply that exponent to all pieces separately. Our negative exponent rule, where a is not equal to 0, if we have 1 divided by a to the negative m, we can take that base a and move it from the denominator to the numerator, making it a to the positive m. If we start with a to the negative m, we want to get rid of that negative exponent, so we're going to move that base of a from the numerator to the denominator in order to make that a positive exponent m. And then our last rule or property is what happens if we have a fraction raised to a negative exponent. Remember, you can then reciprocate or flip the fraction inside your parentheses, and then that makes the exponent become positive m, and then you can use your power of a quotient rule and apply positive m to b and positive m to a. Our first example we're going to use our properties of exponents and simplify when we can. So notice first we have y raised to the 4/5, so we have a fractional exponent, and then this is times y raised to the 7/5. So we're using our first property, which is product, like bases multiplied, we're going to add those exponents. So we're going to take y, and we have 4/5, and we can add it with 7/5. Now, one of the things we have to notice is that we already have common denominators. So this is going to be very important for what you're going to be doing in the future. Is if I don't have a common denominator as is, I need to get one. So since we have our common denominators between 4/5 and 7/5, we can simply add the numerators. And so this gives us a total of 11/5. Your question is to simplify a raised to the 2/3 times b times a raised to the 4/3. Notice we have like bases, and so use your rule in order to simplify this expression. Our next example is quite a bit more involved than our first one. So I want us to take some time to process all of the information that's going on here. So there are different ways to attack this problem. The first thing that I'm going to notice is we have numeric coefficients in both the numerator and the denominator. We have a 9 in the numerator, we have a 3 in the denominator. And so division is occurring between those two. So we need to process the fact that 9 divided by 3 is 3. And 3 is a whole number, and it's going to go in our numerator because 9 divided by 3 is 3. It is not 1/3. If it was 1/3, then 3 would be going in the denominator. The next thing I'm going to notice is we have w to the 3/2, and then we have w to the 1/2, but that w to the 1/2 is in the denominator. And remember, like bases divided, we're going to subtract those exponents. So that gives us w to the 3/2 minus 1/2. And we'll be able to subtract those in our next step. The next thing I'm going to notice is we have a negative exponent. So we're using our negative exponent rule that says I need to change my negative exponent to positive by moving the base of that expression from its current position in the fraction to the opposite position, meaning w to the negative 2/3 is in the denominator. We're actually going to move that to the numerator to make it a positive 2/3. Now our next step, and I'm going to connect these with equality symbols. Our next step, the 3 remains the same. We're done with that. We have w to the 3/2 minus 1/2. We have a common denominator. And so w to the 3/2 minus 1/2 is literally w to the 2/2, which simplifies to be 1. So I'm going to do that work up here. 3/2 minus 1/2 is 2/2, but 2/2 is equivalent to 1. And then we have w to the 2/3. Remember, like bases multiplied, we're going to add those exponents, and 1 plus 2/3 is equivalent to the mixed number of 1 and 2/3. And I'm not sure if you remember how to convert from a mixed number to an improper fraction. The steps to do so, we take our denominator of 3, we multiply by 1, and then we add 2. And so 3 times 1 is 3. 3 plus 2 is 5. And so this is equivalent to 5/3. Now this would have given us the same thing if we had gotten a common denominator. Now 1 is a fraction. It is 1 over 1. But I need a denominator of 3 so I can actually add with the 2/3. So 1 rewritten with the denominator of 3. Ask yourself this question. What divided by 3 is equivalent to 1? And the answer to that is 3. Isn't 3 over 3 equivalent to 1? And isn't 3/3 plus 2/3 equal to our 5/3, which we got from converting that mixed number into an improper fraction? And so this is now simplified fully to be 3 times w to the 5/3. You have a question here very similar, and I want you to make sure that you take your time and work through this problem, and also make sure that if you have any questions or you're struggling or frustrated, you can always contact me either through Remind or email or stop in, and make sure that you know that we are here to support you. And we have two more examples that are very similar to each other. So I just want us to take a moment and see. Inside our parentheses, we have 8 times x to the 3/4 for both example numbers 3 and 4. Now for example number 3, our outside exponent is 1/3, whereas for number 4, our outside exponent is negative 1/3. So we're going to have to deal with that negative. Let's tackle problem number 3 first. Now notice 8 and x to the 3/4 are both inside our parentheses, so that means we're going to be using our power of our product rule, which means 1/3 is going to apply to both the 8 and to the x. So we have 8 to the 1/3, and we also have x to the 3/4 raised to the 1/3. Now we've been working with rational exponents for simplifying numeric bases, and we can do so by remembering that an exponent of 1/3 actually means cubed root. So we have cubed root of 8, and then we're going to use our exponential rule for x to the 3/4 raised to the 1/3, which is our power rule. Raise a power to a power, we're going to multiply those exponents. And what do you notice there? Do you see that we can simplify those fractions? What cancels? Do you notice that we have a numerator of 3 and a denominator of 3, which will cancel? So this will give us x to the 1/4. And then do you remember what the cubed root of 8 is? The cubed root of 8 is 2. And just as a reminder, the cubed root of 8 is 2 because 2 raised to the 3rd power is 8. And that problem is done. Now our last example, we're going to jump right to the fact that this is raised to a negative exponent. And remember, our negative exponent rule says in order to make an exponent go from being negative to positive, we need to move the base to the opposite position, meaning it is in the numerator. We're going to move it to the denominator. So that gives us 1/8 times x to the 3/4 raised to now the positive 1/3. But isn't this exactly now what we had from problem number 3 right here? This is all the same. And so this will give us 1/2 times x to the 1/4. Make sure you take some time to process that. And your last question, you're asked to simplify the quantity of 64 times x to the 4/3, all raised to the power of 1/2.